Hello students, this is the exit slip from lesson 5 in unit 5, which was exponential functions. The exit slip talked about compound interest formula. It talks about Ariella charging holiday presents to a credit card, and then she forgets to pay it off for several months. Her credit card charges her 3% interest per month. Some students thought that this meant she doesn't have to pay as much, like the amount, which was $450, was going to go down to, I don't know, maybe like $430 or something like that. The way credit cards work is that you borrow money from the credit card company, and if you don't pay it back, they charge you interest. Charging you interest means they require you to pay more money than you started with. So if you thought it was subtraction, it actually was addition. Now, a useful thing to do in this situation would be to start with the exponential interest formula. And that exponential interest formula is this. Ta-da! That exponential interest formula uses several things, which I will write down here. The first piece is P. P stands for the principal, or the starting amount. And then 1 plus or minus. The plus or minus is the thing that I just talked about, whether it's adding or subtracting from the value. The R, or lowercase r, should be equal to the rate of increase or decrease. And the T, as you could well imagine, T stands for time, the amount of time that's going by. So how much money does she owe after 1 month? What we can do is fill in this formula based on this information. We know that A is the thing that we're looking for. P is the principal, which is the starting amount, so we'll put 450 there. 1 it represents we're starting from 100% of our value. And in this case, we're adding value to it. We're adding amount of money that we have to pay to the credit card company. R is our rate, but before I write that down, think about what rate actually means. In this case, we're dealing with a percentage. They give us a percentage, 3% interest. But that percentage can't be put into this formula just as is, because the formula talks about 1 in terms of 100%. So we need to change 3% into a decimal. 3% as a decimal is equal to, 3% is equal to 3 divided by 100. And we know that's 0.03. Percent means divided by 100, so 0.03 is the piece that we need. Let's see if I can pick up where I left off here. 0.03, and close parentheses. The power, the exponent that we're looking for, is the time, and the amount of time here, we just had it after 1 month. So we'll write in here to the first power. If we throw that whole thing in the calculator, we get an answer of 463.5. Now we're talking about money. So if you put 463.5, that's not really accurate. We're talking about $463.50. So throw that in there, $463.50. Write an equation that represents this situation. You could have simply written down the equation that's here, except substitute in the information that we know. A equals, P is the principal, which is 450, 1 plus 0.03, and the power here, we're not talking about the situation from A. We're not talking about this situation. We're talking about the situation with the credit card. So we're not going to use 1 as our exponent. We are going to use the letter T. T represents the time that's going by. Now, last but not least, we're supposed to use the equation to determine what she owes after 10 months. So we're going to take the equation that we just wrote, which is this guy, and we're going to bring it down here. The information that we were just given is the 10-month figure. That 10-month figure is going to go into our formula, our function. So rewriting the formula is going to be A equals, capital A equals, pardon me, 450 times 1 plus 0.03 to the power of 10, to the 10th power. Let's see if I can throw that up there. Put a little superscript. And when you put that into the calculator, you should get $604.76, blah, 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 blah. But we're not going to put all that nonsense. We're rounding to dollars and cents. So $604.76 is our correct and complete answer.